Hello, hello, hello. Welcome back to Hydroponics Daily, your go-to podcast for everything soilless cultivation. I'm your host, Dr. Russell Sharp of Yuri Limited, and we make interesting fertilisers, novel biostimulants and organic biopesticides here in the UK, but we also sell all around the world. And today's topic is really interesting. The episode is going to be about growing crops in space. Now, I've done Mars, I think, in the past, probably done the Moon, but space is a novel one. And this is actual research that's come out of NASA and published in Nature. So you don't get more prestigious than that. Nature is the #1 journal for natural sciences, should we say, alongside Science Journal. And NASA is NASA. Everyone knows NASA. So what have they found? Well, we've all thought that, growing crops in space is, it's going to be the thing to do. But they cultivated crops on the International Space Station, the ISS, and they found that the lettuce cultivated in orbit contained approximately 30% less calcium and approximately 25% less magnesium than its Earth-grown counterpart, alongside variations in iron and potassium levels. Now, this is important because when you think about the human body, it loses bone density and bone strength in space, in microgravity and zero gravity if you're going beyond the Earth's atmosphere, Earth's gravitational field, sorry. And so you're going to need calcium-rich food. And so this is going to be an issue. Now, I have not done much research into this topic. I would imagine it's probably due to the humidity on the ISS and lack of evapotranspiration, the fact they're using LED lights, and they're probably using bog standard hydroponic fertilizers rather than liquid gold or gold leaf as it's called in the US, which would be loads of calcium, especially if you used a CalMag with it. So let's do some research into this and find out just what is going on the International Space Station. Well, it looks like the situation is even worse because the space-grown plants also had fewer protective molecules and more stress compounds affecting flavour and nutritional density. So probably more astringent taste, but also less antioxidants, the antioxidant levels. So astronauts undergo genetic and metabolic changes in space. So they are receiving more radiation from the sun because they're not protected by the Earth's atmosphere. Then that could be a real issue. And so that combined with the bone density issue. And some astronauts exhibit signs of a leaky gut, a condition that impairs nutrient absorption and increases inflammation. So makes it even worse. So that could be a real issue. And the scientists have put it down to microgravity changing how plants absorb nutrients and distribute water and respond to oxidative stress. I'll have to look into it, see if they compared it to a similar growing environment on Earth. I'm sure they did because this is published in Nature, so that would be one of the big issues. So microgravity really having an effect that wasn't expected, or certainly wasn't obvious. Might have been, some of the boffins might have expected it. So what are they going to do about it? Because you can't just say, right, we can't travel in space because of this. We've got to get to Mars. Elon wants us all to go to Mars. So we've got to get there. So what are they going to do? They're going to look at bioengineering. So I'd imagine like GM crops. Biofortification. Can you use things like novel fertiliser technologies to get the calcium, the magnesium, the iron levels in there? And look at flavonoid-rich plants to increase the body's ability to combat that stress, the radiation stress and the other stresses of being in space. So the flavonoid-rich plants, that might mean that they're switching out lettuce for spinach or kale or maybe tea, apples and citrus, all high in flavonoids, which are really good at combating stress. Let's see if we can find the actual Nature article, because normally Nature articles are free to read. So we'll open that up and see if we can find more information about the materials and methods used in this trial. Well, that took me longer than it should have, because it's not actually published in the journal Nature. It's published in one of the Nature's subsidiary journals called NPJ Microgravity, which doesn't have the same kudos, but it's still a very good journal, so I won't badmouth it too much. So the actual article wasn't what I was expecting. It wasn't really this is the methods, this is the results, and this is the discussion. It was a sort of meta-analysis of a few different studies. So I'm going to assume that the control treatment on Earth was the same environment and that it was the microgravity that was causing the reduction in nutrients, which makes for a good story. So hopefully they did, proper scientific merits. I'm sure they did if they went to the expense of putting an experiment on the International Space Station. Now, what's interesting, really, apart from the leaky gut syndrome, which sounds disgusting, doesn't it? A bit like, when people eat, do you remember when they developed those crisps that you couldn't absorb the fat from them, so they're really good if you were dieting, but it turns out they gave everyone what was described in the news as anal leakage. Leaky gut syndrome seems like that, like diarrhea on the ISS. I couldn't think of anything worse. Apart from that, there is a graph. There is a table that gives you all of the nutrient breakdown of the crops that are space relevant. So those that have been proposed for growing in any space mission. And what's surprising is the one that seems to be really good is soybeans. And soybeans, like we talked about yesterday when we talked about edamame, is that they're a legume and they're also a short, stocky legume. And so they could potentially be grown in vertical farms, but obviously they're a low value crop on Earth. But if you can get crazy high levels of, so the calcium level, for example, in lettuce, 36 milligrams per 100 gram. In soybeans, 277, and that's repeated across the board. And it is it's a seed, so obviously that's more relevant. But that's really interesting. There's a lot of research that's been done on soybeans and a lot of GM soybeans as well. So that is particularly interesting. So that graph was really interesting. Flax was really high in calcium as well, as was sunflower seed. So basically seed is high in wheat, is high in magnesium as well. So just looking through the data there, a bit like, Rain Man though here, it's not great. So yeah, that's particularly interesting. So yeah, potentially soybeans on space missions rather than lettuce from now on. Although pollination would be a bit difficult. But can bumblebees fly in microgravity? There is a question for you. Can a bumblebee fly in microgravity? Answers on a postcard to Utrema Limited, Daventry, England. Also, when we talk about legume crops, I wonder if peanuts can be grown hydroponically. I am going to look at that tomorrow because peanuts are unusual because they sort of bury their peanut underground, aren't they? The one sort of fruit that you get underground. But can you grow them hydroponically in, say, rockwool or ebb and flood, and then harvest them easier rather than digging up the soil, and better for regenerative and protecting the soil? I don't know. I'm going to do 3 legume topics in a row on this podcast. The other advantage of soybeans, as we said, is that they absorb nitrogen from the air, and so you wouldn't need nitrogen fertiliser if you were going to Mars. So cut down, you wouldn't need a big Haber-Bosch factory on Mars or in space. So, but probably the least of your worries. All right, that's enough waffle for today. If you found this interesting at all, please get in touch. If you've got any questions, leave us an Apple Podcast review. That really helps spread the podcast. We got to number 22 in the gardening podcast charts in the UK, which made my day. But we can get higher. It's terrible rain here in the UK. It's driving down. It's awful. All the roads are flooded. The motorways are closed, which means no one's in the garden and no one's listening to gardening podcasts. So if you can leave us a rated review and that this is the time to strike and increase the Hydroponic Daily and get hydroponics into the news and into the charts. If you're not on Apple Podcast, don't bother leaving a review because it doesn't help with any charts. But just make sure you follow the podcast and check out utrema.co.uk because you might find something really interesting. And we sell mainly in the UK, but we do have distributors abroad. So if you're listening to this abroad and you're in a position to distribute products, then get in touch. We're always happy to speak to new people. And yeah, we've got some exciting events I'm going to plan for all our distributors soon. Here in the UK, I want to do a meetup at like either the Royal Horticultural Society or Kew Gardens and have a meeting and talk strategy and things like that and have a nice walk around some gardens. All right, that's enough waffle for me today. I'm really grateful for you listening to Hydroponics Daily. I'm going to go to the pub because it's Friday evening. All right, ta-ra. See you tomorrow. Goodbye.